Hey everybody, here's the lesson 5 homework practice for tonight. I'm going to go fast because on this video you can stop it and watch it again or pause it as often as you like. The first question I'm going to help you with is number 2, which is the fraction 2/9. That's not 2 and 2/9, that's just 2/9, okay? So we think about it like this. If I've got 2/9 as my fraction, first thing I kind of want to think about is, can that easily be made into an equivalent fraction that has 10, 100, or 1000 as the denominator? Because I have a tenths and a hundreds and a thousandths place. If I could just do this easily, I would know what the decimal is pretty easily. But no matter what I do or how I play around with these numbers, I'm not going to be able to do that easily. I tried here. I did 9 times 10, which is 90, and then divided it by 9 to get to 10. But the problem comes when I try to do the same thing to the numerator. 2 times 10 is 20, but I can't divide 20 by 9 evenly because 9 doesn't go into 20 an exact amount of times. You're either going to be under or over 20. So that's not going to be a good method for me to find an equivalent fraction in order to make that a decimal. So I go to my second strategy, which is dividing the numerator by the denominator. So all fractions are division problems. 2/9 or 2 over 9 is the same thing as 2 divided by 9. So I set it up as a division problem in order to find my decimal. Okay? I need to do this correctly. This says 2 divided by 9. This says 2 divided by 9. This also says 2 divided by 9. What students often do is they put the 2 outside the division bracket because they want to read it left to right. That is not the way a division bracket works. You need the number you are dividing underneath the bracket, the number you're dividing by outside. So this would be the proper way to set that up. When we do this correctly, this is a 5th grade skill. Dividing with decimals is something they did in 5th grade. So we talked about how many times does 9 go into 2. If I have 2 parking spaces, can I fit 9 cars into those 2 parking spaces? No. It goes in 0 times. 0 times 9 is 0. I'm subtracting now, and I get 2, and I need to bring down the next number. There's not another number. I'm back to how many times does 9 go into 2 again. But with a decimal, I can bring down as many zeros as I want to help me. So I bring down a 0 and make it 20. Well, 9 does go into 20 parking spaces. If I have 20 parking spaces, I can fit 9 cars in there once. I can also fit 9 cars in there twice. 2 times 9 is 18. If I go 3 times, that's too much. I'll go over 20. So I can only go 2 times. Now I subtract. 20 minus 18 is 2. And if I want to bring down another 0, I'm going to be right back at 20 again. Interesting. So I know it goes 2 times. 2 times 9 is 18. And I subtract and I get 2 again. And so what I'm finding is that I'm going to fall into this pattern of no matter how many zeros I bring down, I'm going to keep getting a remainder of 20. And that's going to keep leaving me with 2's as I continue on here to find this decimal. That's called a repeating decimal. There's no sense in writing it over and over and over again. So we simply write this as 0.2 with a bar over the digit that repeats. That's called a repeating decimal. And I can stop there at 0.2 with a bar notation. All right. So to answer that question, I would be looking for 0.2 repeating or 2/10 repeating. Okay. All right. That's one example. Another example would be if you had a negative number. Okay, first I always try to think, is there an equivalent fraction with a denominator of 10, 100, or 1000? Well, there doesn't need to be because this already has a denominator of 10. It doesn't matter that it's a negative number, it still already has a denominator of 10, so I don't need to find an equivalent fraction like this. I can go ahead and say this is 3 over 10. That's like a 3 in the 10th place. So I'm going to use my place value. I don't have any hundredths. I could put a 0, but I'm not because I don't even have hundredths. I just have tenths, so I'm going to stop there. I don't have any, there's no number in front of the fraction, so I don't have any ones. Okay, this is simply just 0.3. But don't forget, it was a negative fraction to start with, so it's still negative when you convert it to a decimal. All right, so pay attention. Sometimes you don't have to do any division if you already have a denominator of 10, 100, or 1,000. All right, so started as a negative fraction, ends as a negative decimal. Okay, one last example for you. This is number 22. When you have a integer in front of the decimal, okay, this is saying -2 and 42 hundredths, which if you convert that quickly, we're going to the hundredths place, so our denominator is 100. So there's our 42, there's our 100ths. We leave the integer that's in front of it, -2, we leave that integer alone. It's still -2. We don't do anything with the integer while we're doing this. So there's our fraction, okay? We went from a decimal to a fraction this time, okay, instead of from a fraction to a decimal. But there it is. The problem is it's not in simplest form. So whenever we can simplify a fraction, we do that. You should start to notice, hey, these are both even numbers. I can divide them both by 2, or maybe if it's a different number, you understand, hey, I can divide them both by 5, or I can divide them both by 3, or whatever. But this one, both even numbers, so we can divide them by 2. Again, we're not going to do anything with this negative integer in front. We're going to just treat it like 42 over 100. So I just carry the integer over here and put it back. I divide this one by 2, I get 21, and I divide this one by 2, and I get 50. And I look and check, can this be any simpler? Can I take this down further, just the fraction piece? And no, the only factors I have of 21 are 1 and 21 and 3 and 7. 50 has a few factors, 1 and 50, 25 and 2, 10 and 5, but it's not going to share the 3 or the 7 with the 21. So I can't do anything. I can't divide them both by 2. I can't divide them both by 3. I can't divide them both by any number. So that is my simplest term. So it's still negative. I left the whole number alone, just like I left it alone up here. It is a negative fraction now, -21 over 50. Okay? So there's 3 examples for you. I told you I would give you 3. I've given you 3. And I'm going to show you one more thing. This last question, number 26, I'm not going to show you how to solve this, but I am going to talk about it a little bit. Jake won 7 of the 15 races he ran. Express Jake's fraction of wins as a decimal. Okay? Well, you don't have a fraction. It doesn't exactly look like a fraction, but what you have is 7 out of 15. I'm assuming that 6th graders can figure out how to make the fraction when it says 7 of the 15. Think about your part over the whole, because that's all fractions are. The part you're talking about, or the part you have over the total, or sometimes we say over the whole thing. All right, so hopefully you can set up the fraction correctly in number 26, which will allow you to convert it to a decimal correctly. All right, hope this helps with your homework tonight. And as always, it is due tomorrow first thing when you come into class. You're doing even numbers only on this sheet, and I've already helped you out with a few of them. You should have taken your journal home. You have lots of examples, so my expectation is that you will do really well on this practice, and it will help us as we move on to the next lesson. Talk to you soon. Have a good night.